guys, welcome once more to another video in our YouTube channel. In this video we are going to be solving a physics problem whereby we are going to combine direct collision together with projectile motion to solve this problem. So for those of you who have not yet subscribed to the channel, please endeavor to do so. After subscription, always turn on your notifications so that whenever videos have been uploaded, you'll be notified to come and watch. Okay guys, so here is the equation displayed to you. You have a diagram and then the description of the diagram. So the equation reads: figure 1 shows a bullet of mass 8.0 gram fired horizontally into a block of mass 250.0 gram, which is at rest at the edge of a table whose height is 1.00 meters and embeds in it. Both masses move together, traveling a horizontal distance of 2.00 meters. Find the initial velocity of the bullet. So before you continue, please pause the video, try the equation by yourself, 00 meters, and definitely a vertical distance of 1.00 meters. Now both of them have a common velocity because the bullet embedded in the block. So the objective of the equation is to find the initial of the bullet embedded in the block, so they have the same velocity finally since they move together. So applying the principle of conservation of linear momentum along the horizontal table, we have the initial momentum of the bullet plus the initial momentum of the block to be equal to the final momentum of the bullet plus the final momentum of the block. Now, since initially the block was at rest, it means that its initial velocity is 0, as I previously said. So from there we can get the initial velocity of the bullet to be the final velocity of the bullet, which is the same as the final velocity of the block, times the sum of their masses divided by the mass of the bullet. Now we have the mass of the bullet, we have the mass of the block, but we don't have their final velocity, that is their common velocity after collision. So we are now going to use the second scenario, that's the projectile motion, because the first scenario we consider motion on the horizontal table. Now the second we are going to consider the projectile motion. So we are going to consider that to find their common velocity. And before doing that, first of all, we are going to find the time of flight, and know that the time of flight both in the vertical direction and the horizontal direction are the same. Now when we consider projectile motion, know that motion occurs in two directions. It occurs in the vertical direction and it occurs also in the horizontal direction. But we should also note that normally an initial velocity in the horizontal direction, as you can see the direction of my velocity v of dv. But if you consider in the vertical direction, the initial velocity is 0 because definitely there is no initial velocity in the vertical direction, just in the horizontal direction. So we now use our equation of motion, which says that the distance covered is equal to the initial velocities of both of them times the time plus half times et squared. Now if we use the displacement, remember that since it was going downwards, it means that it's actually covering its depth, right? So the displacement becomes negative because it's going downward. We consider the direction. Remember, displacement is vector quantity. It has magnitude, which is a distance, and the direction, and it has direction as well. So going downward, if you consider the displacement, then as well you are going to consider the acceleration to be negative, which is just negative g. But if you are considering distances, we are going to consider just the distance here to be 1, and then the acceleration just to be g. But since you are going downward, it simply means you're actually decelerating, so your acceleration becomes negative. Alright, so considering the displacements, right, displacement and acceleration, we have the displacement to be -1. If you want to use a distance, it depends on you. You're just going to put 1. Now since you are considering motion in the vertical direction, means there is no initial velocity for both particles because their initial velocity is just in the horizontal direction, which is v b. Alright, so ubb is 0 times the time plus half times, since we consider the displacement to be negative there, it was decelerating, right? So acceleration becomes negative g, negative 9.8 meters per second squared, times our t squared. Remember that if here I use the distance, then my acceleration here, I'm just going to take the magnitude, which just gives me 9.8. So with that, we can get t squared by dividing both sides by 9.8 and then crossing multiply with 2. So we get t squared to be 2 divided by 9.8 seconds squared. So our t will be equal to plus or minus the square root of 2 divided by 9.8 seconds. Then now, what do you know about time? Time is always positive, so we take the positive square root. So this is the approximate value for the positive square root. That's our second equation. Okay, now we have succeeded in getting the time of flight, which we know that it is constant in both the vertical direction and the horizontal direction. So now we are going to find their common velocity after impact. Yes, since they move to the common velocity after impact. Now we are going to now consider motion in the horizontal direction. So considering motion in the horizontal direction, we have the horizontal distance that was covered as 2.00 meters. We have now in the horizontal direction the acceleration is 0. We all know that in the horizontal direction the acceleration is 0 because it is projectile motion. Now what about the velocity? Initial velocity in the horizontal direction is just v of b. Remember that considering the first case scenario, the final velocity in the first case scenario becomes the initial velocity in the second case scenario. So the final velocity in the first case scenario was just their common velocity, which is this. Now it is in turn it automatically becomes the initial velocity in the second case scenario. Yes, and remember it is in the horizontal direction. So with that said, we use the same because we know the distance covered in the horizontal direction. The initial velocity is what we are looking for. The time of flight is constant in both directions. We have calculated it already. The acceleration in the horizontal direction is 0. So with that said, we can get horizontal distance covered is 2 meters. Our v of b is what we need, and our t we just calculated it as we approximated it to 0.45175 seconds. Acceleration in the horizontal direction is 0, so that term there becomes 0. The piece supposed to be squared here, but anyway the term also becomes 0, so no need. Okay, so with that we can divide both sides by the time of flight, and then from there we try to approximate the value of their common velocity after impact in the first scenario, which is actually the initial velocity in the second scenario. So it approximates to 4.4272 meters per second. That's equation 3. Now from equation 3 and equation we can take now equation 3 and we fit in equation 1, because we just needed, since we have the masses already, we just needed this velocity to get the initial velocity of the bullet. So fitting it there, we have the masses as 8 and 250. Where we add the 2, we get 250. We now multiply it with the velocity we have calculated and we divide it by 8. So approximating, we get our initial velocity of the bullet to be 142.78 meters per second. Alright guys, so thank you for watching and see you in the next video. Make sure you comment on the video if the video is good. Like the video as well and share the video with your friends. Share the channel link as well so they can discover the help that the channel offers. Thank you.